All right, ladies and gentlemen, we're going to talk about gravitational forces, okay, and what impacts gravitational force. Now, because I am actually covering something that's currently not in my curriculum, I need a little bit of help in terms of knowing what to cover, so pardon me for using paper. Okay, so we're talking about what a gravitational force is and what factors affect a gravitational force. So first of all, gravitational force is a force that's exerted between objects. We most likely associate them with planets or other interstellar objects, and they're the force that attracts them to each other. Okay, so what factors affect gravitational force? Well, there are two factors: the mass, size of an object, and the distance between the objects. Okay, so, the amount of matter or the mass of the object, okay, and that usually goes hand in hand with the size. Although if you look at our planets, our four planets on the inner portion of the planets, Mercury, Venus, Earth, and Mars, the terrestrial planets are actually much smaller, but they are denser than the larger Jupiter, Saturn, Uranus, and Neptune. However, the larger planets are still so big that they still contain more matter overall and are still more massive. Okay? So if you were to look, two objects that are really large and close together will have the greatest gravitational pull. Okay, so greatest gravity. Okay, two objects that are small and far apart, these objects will have the lowest gravitational pull. Okay? So, if you have a combination of a large and a small planet, so you would take the ratio of the distance and the ratio of the masses, and you would use that information to calculate what the total gravitational pull is. The further the planets are, the smaller the gravitational pull. The closer they are, the greater the gravitational pull. The greater the masses, the greater the gravitational pull. The smaller the masses, the smaller the gravitational pull. So the reason why our planets are kept where they are in our solar system has to do with A, the masses between them and the sun, and B, the distance that they are, and they're kept there primarily because, for example, if Jupiter was any closer to the sun, there's a possibility that it would actually get pulled into the sun because its mass is so great. It is so large itself that the distance would be too close to be able to maintain an orbit, and it would crash into either one of the terrestrial planets or head towards the sun. Okay? The difference between mass and weight, okay? Mass is the amount of matter an object contains, okay? So the more matter an object contains, the greater its mass. Okay? Weight is how gravity impacts that mass. For example, if I took a bowling ball that weighed 10 pounds, okay? Or let's say 12 pounds, let's make the numbers a little bit easier. And I weighed that ball on Earth, it would be 12 pounds on Earth. But if I then took that bowling ball and put it on the moon and weighed it on the moon, the gravitational pull of the moon is 1/6 that of Earth. So the total weight of that bowling ball on Earth as measured would be 1/6 that of, on the moon, would be 1/6 that of the Earth. So whereas it would weigh 12 pounds on Earth, it would only be 2 pounds on the moon. So if you were to take the mass on Earth and you were to take the mass on the moon, the masses would be completely the same. Why? Because although the weights are different, masses are a universal unit. 12 grams of a substance substance, for example, or 10 grams of a substance on Earth, and use a triple beam balance to mass it out, and then I took that 10 grams onto the moon, it would still impact the scale the same way, because if I were to measure an item and balance it out to get the same result on Earth, whatever the result is on the moon would be the same. So the masses would never change because the amount of matter doesn't change. So what a triple beam balance does is a triple beam balance actually measures the mass of an object or the amount of matter in an object. Now, is it going to show up as exactly the same on the Earth and on the moon? No, because it doesn't weigh as much. It's not going to impact the balance the same way, but 10 grams of an object is going to behave exactly the same way to an unknown substance if you were to mass it on Earth and on the moon. So if you were to use an equal arm balance, for example, if you were trying to find the exact same mass as 10 grams of a substance, it would equal out on the equal arm balance on Earth. It would equal out on the equal arm balance on the moon, because the masses would have to be the same, so they would behave the same way. So in a triple beam balance, again, it is used to measure mass. It measures the mass based on grams, and then it goes down to decigrams and milligrams. So you're able to take it to a very small place to be able to get. So I think I pretty much covered that. Oh, and by the way, there was one thing I do want to mention when we're talking about forces. Yes, both objects do actually exert a force on each other. So this object, let's say this is the Earth, and let's say this is the sun. The Earth exerts a force on the sun, and the sun exerts a force on the Earth. So objects do exert forces on each other. So I hope this was helpful in terms of covering these concepts. If you have any questions, please go ahead and drop me a line, and I'll be very happy to answer any questions that you may have. Take care and have a wonderful night.